Hi everyone, we're starting video 13, and what we're going to be looking at is we're going to start looking at different types of transformations. And the first transformation we'll be looking at will be translations, or moving our graphs up and down, left and right. So up along the y-axis vertically, or along the x-axis horizontally. Now, this section, this new section that we are entering is actually section 14E in your textbook. And the whole chapter, the whole section of 14E is basically chapter 7 in your textbook. So we're basically inserting a chapter inside of another chapter. So inside of chapter 14 we're going to be doing now chapter 7, and we're going to be looking at translations, the three different types of transformations that we have. We're going to be looking at translations, we're going to be looking at reflections, and we're going to be looking at dilations. So translations is what we'll be looking at today, and we'll be looking at translations that go along the y-axis. So that means when we are moving our graph vertically up and down. And then we'll be looking at translations along the x-axis, which is moving our graphs left to right or right to left. Okay, now we're going to start off with an actual movement of a graph. This is in exercise 7A, so we're looking at from your textbook, section 7A, and we're going to start with vertical translations. So vertical translations really simply means that if I have to take a physical graph, so I've got, visually I have a graph in front of me, so my graph is, let's say in this case, is f of x, it's the black graph here. I've called that graph f of x. Now, f of x, I want you to move it down vertically 3 units. So what that involves in the moving of the graph down 3 units is that the graph is going to be moved vertically down 3 units. So it's the y value that's going to be affected. So if I have a point at 3, 4, since my y unit is at 4, when I subtract 3 from that, it will take me to 3 and 1, because 4 minus 3 gives me 1. So that my new point will be found at 3, 1. The point 5, 2, vertically, 2 minus 3 will give me negative 1. So my new point will be 5 and negative 1. And my point 1 and 2 will go to 2 and negative 3, which is negative 1, so it'll go to 1 and negative 1. So essentially, when I am working on translating a graph or moving the graph physically, if I am translating the graph vertically, I am going to move it down or up a y number of units. So my x-coordinate does not get affected of any ordered pair. My x-coordinate does not get affected, and my y-coordinate is the one that changes. So the x-coordinate remains the same, it's constant, and my y-coordinate will change according to what the shift that you're being asked to do is. Okay, so if I say, and I have to describe this movement, so if I have to describe this movement of moving the graph down 3 units, so if we have if we have f of x equaling that black graph, and I want to express that I'm moving the graph down, I'm going to say, as is written here in red, I'm going to say f of x minus 3. Now, why am I going to say f of x minus 3? Where the minus is on, minus 3 is outside of the f of x. Remember that f of x stands for y. And if y is the coordinate that is being moved vertically up or down, if I say y minus 3 or f of x minus 3, that's as if I were saying I'm taking my y-coordinate and I'm moving it down 3 units. Okay? So, moving on, let's take a look at another example. We've got here a parabola, and the parabola this is a function. Now, if I want to move the black function, so that I have here the black parabola, I want to move it up 2 units vertically, then the way I would describe it would be I would take my f of x function, which is written right here, it's an f of x function. I would take my f of x function right there, and I would just add 2 to it to show that all of my y values are going to be moving up by 2 units. Now, I realize that the graphs are off of the squares right now, so it's hard to see it, but I have moved the graphs up 2 units and down 3 units and so forth accordingly, and I've done it correctly. Okay, so I would describe the graph being moved up as f of x plus 2, and what that means is that all the y values are being shifted up 2 units. Now, the basic or general rule that we use in translating a graph vertically, so when we're physically showing, we're going to show what where the new graph is going to be that my values of the x and y, whatever they are on a graph, they will go to x and y plus k. Y plus k, where k is the constant or the number of units that the graph is either going up, if it's plus k. So if it's plus k, my graph is moving up k units, and if it's minus k, my graph is moving down k units. Okay, next one. So if we want to express a vertical or a horizontal translation algebraically in an equation, we can use what's called vector notation. Okay, so what we're doing is we're going to be looking at vectors. So because I'm going to write this down as hk, so I'm going to write down a vector that's hk. This is just another way of writing our xy coordinates. Instead of writing them horizontally this way, so if you look at the hot pink values here that I've written the letters, the coordinates, the value hk could be xy. Okay, and hk, if I write it down vertically as opposed to writing it horizontally from left to right, if I write it out vertically, the h stands for my horizontal translation, so it's my value of the x, really. Okay, that's my value of the x. And the value of the k is going to be my vertical translation, which is nothing more than my movement of the y. So if I am given something such as 0 and 4, for example, well, that means that I'm going to be moving my graph horizontally 0 units, and I will be moving my graph vertically, because it's positive, I'll be moving it 4 units up. So it'll be 4 units up. I'm just going to put a little up sign there. Okay. So if you're being asked to find the image equation of the following, so you've got y is equal to x squared, and it's under a translation of 0 and negative 2, what that means is that the 0 value, which corresponds to the x coordinate, so that means that's the horizontal movement, it means that if it says 0, it means that there is a 0 horizontal movement. If I look at the value that's directly underneath that, that would be my k unit or my y unit, and that means that my graph will be moved vertically up or down 2 units. So if I had to express y equals x squared, and I had to express it algebraically now, because I'm moving away from doing it the actual movement of the graph, so the graphical method. I'm moving into figuring out, well, if I'm moving a graph, and I know that y is called x squared, if I'm moving the whole graph down 2 units, what's my new equation of that graph going to be? There's going to be a new equation. And so the new equation would just be x squared minus 2, because the graph is moving 2 units down. And remember that we said that f of x, or y, is equal to x squared minus 2. So that this is the y value has to equal the graph, x squared, which is going to be brought down 2 units. So all the y values, there's my y, I've isolated for y, all my y values have to be moved down 2 units. Okay, let's do another example. So another example of this would be if we had, another example of this would be if we had y is equal to 2x, to the 2 to the power of x. Now it's irrelevant what the actual graph is. You may not even know what the y equals 2 to the x graph looks like, but we don't particularly care what it looks like at this point. All we really care about is figuring out what our new equation is going to be once it goes through the translation. So when I look at my equation here, y equals 2 to the power of x, I see that it has a 0 horizontal translation, which means that it's not moving horizontally, the graph. It's not moving left to right. But the vertical translation is of 4 units up. So because the graph is being moved 4 units, and my value, my y is already isolated for, then all I'm doing is I'm saying my new graph, y is equal to 2 to the power of x. In order to get the new graph, it would just have to be, you would just have to add 4 to it, and you're taking the 2 to the x graph and moving it up 4 units. Okay, now things get a teeny bit more complicated as we see that y is not really isolated for. So for example, we've got 2x minus y equals 6. Okay. So there are a couple of ways that this problem could be solved in figuring out what the equation is going to be of 2x minus y equals 6. The first method that I might want to use in getting the new equation is to isolate for y. So I could say 2x, I'm going to change this into blue. I could say, well, 2x minus y, or rather 2x minus 6 is equal to y. Now, because I've isolated for y, that means that my value of y is going to we're going to have to subtract 1 from it. So that I would say 2x minus 6, and because y is isolated for, I will just go to minus 1, and that equals y. So that I end up with y is equal to 2x minus 7. So this would be method 1. So all I would do is I would isolate for y, and I would make sure that my value of y has to be or my function has to be moved down 1 unit. And therefore, I just say 2x minus 6, and then there's my minus 1, because I'm moving it down -1 units. Okay? The second method that I could use, method 2, is maybe a bit more complicated, but it's very systematic. So what I can actually do is I can say, well, my new value of y is going to have to equal my old value of the y minus 1, because my old value of the y has to be moved down 1 unit. Now what I'm going to strive to do is now isolate for the old value of the y. So I isolate for y. Okay, so y prime, the new value, y prime, is equal to the old value, just y, minus 1. And now I isolate for my old value, so that I'll say y prime plus 1 has to equal y. And what I can do now is I can just insert, or substitute, rather. I can substitute, now, y is equal to y prime plus 1 into the given equation, into 2x minus y equals 6. So that I end up getting 2x minus bracket y prime plus 1 is equal to 6. And I end up getting that 2x minus y, now, minus y prime, but because I don't care anymore at this point, because this is my new value of y, this will be my new function, I can now just change it automatically to y. So it goes to 2x minus y minus 1 equals 6, so that we end up getting 2x minus y is equal to 7. And therefore, I have my solution right there. That would be still the same as saying 2x minus 7 is equal to y. Okay, so it's the same as, it's identical to the one that we did in method 1. Okay, so that would be one way of doing this. Let's do another example. So you are asked to find an image equation of 2x minus 3y equals 8 under a translation of 0 and 3. Now, because the first thing I'm going to do is I'm going to take a look at this and I'm going to say, okay, I have a zero horizontal translation, so there's no horizontal translation because it's 0. And we haven't done the horizontal yet either, so we're going to do that next. There's 0 horizontal translation, and we know that the graph is being moved up 3 units vertically. Okay, so I'm going to use the second method that I showed on the last slide. What I'm going to do is I'm going to say, let the new value of y, y1 equal y prime, equal the old value of y, and then it's plus 3. So wherever there is a new value, wherever there is the new value of y equal the old value of y plus 3, wherever there is a y in the equation given above, I will replace it with y plus 3. So I will just do 2x bracket, or rather 2x minus 3 times y plus 3 is equal to 8. And then I'll say 2x minus 3y minus 9 is equal to 8. And 2x minus 3y, when I bring the 9 over to the other side, will go to 17. Okay. Now, the alternative way of doing this, so again, the alternative way is that I let the new value of y equal the old value of y plus 3. The second method, before continuing with the second method, I just realized that I forgot to do one important thing on this first method. And the thing that I forgot to do was that I was supposed to, in the initial part where it said the new value of y, or y prime equaling y plus 3, I forgot to isolate for the old value of y. So it was supposed to become y prime minus 3 is equal to y. And now, so here, where the error is found, is that what I should have done was say that 2 times x minus 3 times y minus 3 is equal to my new value of y, my new value of y, and therefore we've got 2x minus 3y plus 9 is equal to y, is equal first of all to 8. So that now we have 2x minus 3y is equal to negative 1. So that should have been my solution here. Okay, if I use the second method tells me that what I can do is I can isolate for my value of y in the given equation. So I have 2x minus 3y is equal to 8. And I can say 2x minus 8 is equal to 3y. And then I can divide both sides by 3. Okay, so now that y has been isolated, I can say, well, 2x minus 8 over 3, because I need to add 3 to that, my value of y, the values of the y have to be moved up 3 values, then that's going to be equal to y. And therefore, I'll say that 2x minus 8, and then I get a common denominator of 3, so this will go to plus 9, all over 3 equals y. And so it's 2x plus 1 all over 3 equals y. And now if I just manipulate the equation, I'll end up getting 2x plus 1 equals 3y. And now I'll just move my 3y to the left, I'll bring the 1 over to the right, and I'll get exactly the same solution as I did on the left-hand side. 2x minus 3y is equal to negative 1. Okay, so that takes care of the vertical translations. Now, if we're looking at horizontal translations, the horizontal translation means that we are doing a movement of the graph from left to right horizontally, or from right to left horizontally. So again, if we start with the f of x function, in this case, it is the black function again, my f of x function. Now, my graph is found at 2, 1, 3, 2, and 6, 2. Now, what I have done is I have moved my graph 5 units to the left. You can actually see that the graph has physically been moved to the left where we have the red graph. So that if I look at it, I see that my value of 3, 2 has become negative 2, 2. And 2, 1 has gone to negative 3, 1. And 6, 2 has gone to 1 and 2. So what appears to be happening is that the x values are now being affected, in that what's changing is my x values and not my y values. So what we end up saying is that if I want to move my graph 5 units to the left, then I physically move the graph 5 units to the left, so that my x values get affected. So that I have 6 minus 5 will give me the point 1 here, and 2, so because the y values are not affected, it's only the x values. The point 3, 2, when I do 3 minus 5, will go to negative 2, so there is my negative 2, 2. And the point 2, 1, when I do 2 minus 5, will take me to negative 3 and 1. So there is my graph of f of my new graph when I move my graph 5 units to the left. Now, when I have to express that, the actual movement of the graph, so I've got the f of x graph, which is black, and I have to express a horizontal movement, it is not going to be f of x minus 5 like that. Because f of x minus 5 like this means that I have a vertical movement. That's a vertical movement. And it's telling me that the graph is being moved, all the y values, this is my y values, are being moved down 5 units. If I want to express a movement of the x values, okay, then what I'm going to have to write is f of x plus 5. Now, why you're going to say y plus 5 if it's going 5 to the left? Because it's going to be, the symbol will always be in the opposite direction of what we say it's going to be. So if I'm moving the graph 5 units to the left, when I'm expressing that algebraically in the function, it means I'm doing f of x plus 5. Notice that this x plus 5 is inside parentheses as opposed to being this, which I just showed you above. It's not the same thing. Oops. It's not the same thing as saying this. This is a vertical movement. Okay? This is a vertical movement here, f of x minus 5. If I do f of x minus 5, or f of x plus 5, okay, depending on what I'm looking at, if I'm doing f of x plus 5, you see that the 5 is affecting not the y value, f of x, but it's affecting only the x value inside that parentheses. And what I want to change are the x values, not the y. So that if I do f of x plus 5, all in parentheses, that is referring to moving only my x values 5 units to the left. Okay, so if I had, for example, f of x plus 2, that means that because the 2 is inside the x, and it's affecting only the x because it's inside the parentheses, that means that my graph, whatever my f of x graph is, that is being moved 2 units to the left. And if I had, so this would be 2 units left, and if I had f of x minus 2, that would be moving my graph horizontally 2 units to the right. So it's going in the opposite direction. This only works with the horizontal or the x values. Remember that with the y values that we just saw in the previous slides, if it said you were moving your graph vertically 5 units up, then you actually went up 5 units plus 5. If your graph was 5 units down, then you went 5 units down, actually with minus 5. If I am dealing with horizontal translations, then the horizontal translation goes in the opposite direction. So f of x plus 2, all inside the parentheses, means that it's 2 units to the left, and f of x minus 2 means that it's 2 units to the right. All right. So again, this is the explanation that I have. This is very similar to what I had at the beginning of the lesson here. So if we have to look at a general relation or the general equation, then essentially when we're translating a graph horizontally, it's the x values that change, which I already mentioned, and the y values stay constant, and they go to plus or minus. Okay, so it's x plus or minus h, if that's the horizontal movement h, and the y values stay the same, where h is the number of units that the function is being moved, left or right. And I specifically explain here that if the graph moves left, then you're going to have f of x plus h, and if your graph moves right, you're going to have f of x minus h. Okay, so, and again, it's within the parentheses. It's not to be mixed up with f of x plus h, and, f of x, not plus h, but plus k. It's not to be mixed up with f of x plus k or f of x minus k. This means that I'm looking at a vertical translation. This is the vertical translation because it's affecting the y values. Because it's affecting the y values because this is like saying y plus k and y minus k. So it's my y values moved up k units, my y values moved down k units. When the h is found, or the constant that, or the amount of units that we're moving our graph horizontally, is going to be inside the parentheses, and it won't be on the outside of the f of x, but it'll be within the f of x, which is referring to the x values. Okay, so if I want to now do an expression of the horizontal translation algebraically, again, we're recalling what we did at the beginning. We said that hk, when we look at it vertically, the whole thing, when we look at the vertical movement, when we look at the vectors of hk, we said h was the horizontal translation, k was the vertical translation. So if I am given, find the image equation of y equals x squared under this movement, and the movement is a horizontal movement of 4 and 0. So that means 4, 0 is referring to the xy. X is telling you that you are moving your graph 4 units to the right. So we know that we're moving our graph 4 units to the right. The 0 tells us that we're moving our graph in no way vertically, so it's 0. And since it's the x value that's going to change, what I'm going to do is, wherever I have an x in my equation, y equals x squared, wherever I have the x, I replace it. Wherever I have the x, I replace it with x minus 4. It's in the opposite direction. So that stays inside the function. You see that it's not outside. If I had this, x squared minus 4, like this, that would mean that it's a vertical movement of the graph going down 4 units. That's not what I want. I want to show that it is a horizontal movement, and the horizontal movement is going to have to be 4 units to the right in this case, and therefore I have to put it as negative 4 in the opposite direction. All right, so if we want to do very quickly a couple of examples. So one of the examples we can do is, so y is equal to 3 to the power of x under a movement of negative 2, 0. So because you're actually moving the graph 2 to the, you're going 2 to the left, then this is going to become y is equal to 3 to the x plus 2. And there is your function. If I have to do y is equal to 2x minus 6 under a 3, 0 translation, then 3, 0 means that I've got a horizontal movement of 3, and I've got a vertical movement of 0. So it'll become 2 times x minus 3 minus 6. And therefore, it'll go to 2x minus 6 minus 6, which will take it to 2x minus 12. Okay, so if we want to try doing y is equal to 5 minus 2x, that means that wherever I have an x, I will replace it with x plus 2. So it'll become y is equal to 5 minus 2 times x plus 2. And therefore we have 5 minus 2x minus 4. And that gives us 1 minus 2x. So my new equation, algebraically, is going to be y equals 1 minus 2x. All right. Now, of course, we can always combine the two functions. We can combine the two translations so that you have a horizontal translation and a vertical translation occurring at the same time. So here's my actual physical graph that I've taken. So I have my original f of x graph, which is a parabola. And what I'm doing with it now is when I take a look at what the translations are, it says that I'm moving my graph 3 units to the right and 4 units down. So the actual translation is going to be, because it's 3 units to the right, the f of x, wherever there's an x, it will be replaced with f of x minus 3. It's going to go in the opposite direction because it says to move it to the right 3. In the actual problem, it's moving to the right. Therefore, in the algebraic, I'm going to have to place it as minus 3 in the opposite direction. And then the minus 4 is going to go in the direction vertically, as it always does. So it would be minus 4. So this is telling us what f of x is going to, what our new f of x will be. It'll be f of x minus 3 minus 4. So all you would be doing is you would be moving your graph horizontally 3 units to the right and then 4 units down. And although it's not very clear here, it is 1, 2, 3, 1, 2, 1, 2, 3, and 4 units down. Okay? So that's that. Now, if we have to do this algebraically, let's take one of these two examples, and then I'll finish this in class. We'll be able to look at these in class together as well. But let's just do one example. So if I've got 3x plus 2y equals 8 under a translation of negative 1, 3, I can do these simultaneously and say wherever there is an x, I will replace it. Wherever there's an x, I will replace it with the x I will replace with x plus 1. And frankly, what I can do is I can also say wherever I have a y, I'm going to replace it with y minus 3. So that I will have 3 times x plus 1, and then it'll be plus 2 times y minus 3 is equal to 8. So that I have 3x plus 3 plus 2y minus 6 is equal to 8. And then I can just simplify this so that I have 3x plus 2y is equal to, and we'll do 8 plus 6 minus 3, so that we have 3x plus 2y is equal to 6 minus 3 is 3, and 8 plus 3 is 11. Otherwise it's 14 minus 3, which is 11. And that is my new equation. So under a translation of negative 1 and 3. I can do the same thing with the second example. I might as well just do the second one as well, so that I can say wherever there is an x, I will replace it with x minus 5, and wherever there's a y, I will replace it with y plus 2. So that I will say y plus 2 is equal to negative 3 times x minus 5 all squared, so that I will have y is equal to negative 3 bracket x minus 5 all squared minus 2. And that shows me what my new function is going to be. All right. I'll leave this last one for the next class, and your homework or your classwork that you'll be working on in class will be exercise 7A, all of it. So I'll see you next time.